All right, we're going to take a look at graphing in factored form now, and all of the steps are exactly the same. The process might be a little bit different given the factored form versus the standard form. So does the graph open up or down? Our coefficient is positive, so our graph opens up. Axis of symmetry for factored form, we use the x-intercepts, and remember they're inside the asylum. So this -1, when it comes outside the asylum, is an x-intercept of 1. I'm going to write these as ordered pairs because we can use these for our graph as well. And then our other x-intercept inside the asylum, it's positive, so it's really a -5. Remember, an x-intercept is where the graph crosses the x-axis, and it's the value of the function when y is 0. So to find the axis of symmetry with our intercepts, we average them. So I'm going to take 1 plus -5 divided by 2. -4 divided by 2 is -2. So the equation for the axis of symmetry is x equals -2. The vertex, we get the y-coordinate of the vertex by using the axis of symmetry, the x-coordinate of the vertex, and substituting it back into the function. So the f function evaluated at an x value of -2 equals, substituting -2 in, and evaluating order of operations, -2 minus 1, -2 plus 5, and then we get -18. So our vertex is x-coordinate -2, y-coordinate -18. Y-intercept, substituting 0. And evaluating, we get 2 times -1 times 5 gives us -10. So writing that as an ordered pair, we substituted 0 for x, got a y value of -10. Domain for any quadratic is all real numbers. We can substitute any value in for x. And the range, because our graph opens up, y will be greater than or equal to the y-coordinate of the vertex. Make sure you're grabbing that from the vertex again, not the y-intercept. All right, and then we basically just plot all of the points we have. I'm also going to plot my x-intercepts because factored form we have more information. So I've got intercepts at 1, 0 and -5, 0. I have a vertex at -2, -18, so my y scale I will do by 2s so that I can fit it in. So my x scale is still by 1s, my y scale is by 2s. My y-intercept is 0, -10. And the last piece, or step 2 technically, is use the axis of symmetry to reflect the y-intercept. Now, with the points that I already have, I don't really have to do that, but it's a good habit. So I'm going to draw my axis of symmetry. Remember, that goes through the x-coordinate of your vertex. And then the y-intercept here is 2 away from my axis of symmetry, so I'm going to flip it over and go 2 away on the other side. Then I'm going to create my nice rounded parabola with arrows. And that was step 3. All right, I'm going to jump to vertex form, try and do this relatively quickly. All right, opens up or down. Our A is negative. We are multiplying by a negative coefficient, so it opens down. Axis of symmetry. We already have the x-coordinate of the vertex right here in the asylum. Pull that out of the asylum, x equals -2. Substituting that back in to get the y-coordinate of the vertex. I like fractions instead of decimals, so I'm going to convert that. And inside our parentheses, we get 0. 0 squared is 0, times -1/2 is 0, -3. Y-intercept, substituting 0 for x. Sorry, let me back up. I'm trying to do this too quickly. So the vertex is -2, -3, x-coordinate, y-coordinate. using my fraction again. So inside my parentheses, I have 2 squared is 4. 4 times negative 1/2 is negative 2. Negative 2 minus 3 is negative 5. So my y-intercept is 0, negative 5. Domain, always all real numbers. Range, because our graph opens down, it's less than or equal to the y-coordinate of our vertex. So that I don't have to keep scrolling, here are all of our steps. We're going to plot all of the points that we have, use our axis of symmetry, and create our parabola. So I'm going to start with my vertex, negative 2, negative 3. My y-intercept is 0, negative 5. My axis of symmetry goes through my vertex, flipping my y-intercept, and creating my parabola.